Hello everyone. Now we're going to discuss about basic of combination logic circuits, adder and subtractor. First of all, what is meant by combination logic circuit? It's one of the logic circuit. Here the logic gates are connected together to perform some specified Boolean function with the variation of input combinations. So combination logic circuits includes various examples like adder, subtractor, multiplexer, demultiplexer, encoder, decoder, comparator, multiplier. So likewise we can say many examples for combination logic circuit. So in combination logic circuits, multiple number of inputs and similarly one or multiple number of outputs will be there. So based on the variation of input variables, the output will change accordingly. So the combination logic circuit doesn't have any memory unit. I mean, whenever we are changing the input combinations, the output will change instantly. No storage unit here. Next, we'll discuss about adder and subtractor. The next one, adder. Under adder, we have half order and full order. So half order means it's a 2-bit addition and full order is a 3-bit addition. So first we will discuss about half order. So half order is one of the combination logic circuit. So here we are going to perform a 2-bit addition. So we are taking the input combination, input variables as A and B. So while doing a 2-bit addition, so the output will be in terms of two outputs. One is a sum variable, another one is a carry variable. So now we're going to perform this 2-bit addition. So when you're having a 2-bit as the input variable, so what are the possible input combinations? So A may be 0, B also 0, A is 0, B is 1, A is 1, B is 0 and both are 1, 1. So these are the 4 possible input combinations are there. So when you are doing a 2-bit addition. So otherwise we can say, so whenever you are doing any addition or anything, any combination logic circuit, so based on the input variables, the number of possible input combinations will be changed. I mean 2 power n number of input combinations will be there. So here we are having a 2 variable. So obviously 2 power 2 is a 4 input combinations. So we're going to perform these 4 input combinations under truth table. So first we're going to perform this truth table. Then based on the truth table, we're going to do a K-map simplification. Then from the K-map simplification, we are making a logic diagram. For any combination logic circuit, so these 3 steps should be performed. Based on the statement, first we have to make a table, truth table. Then we have to simplify the truth table by using K-map simplification. Then after that, we have to make a logic diagram for that. It's called combination logic circuit. So design. So now first a truth table. So A and B is the input variable. So A is 0 and B is 0. While adding 0 plus 0, the carry value also 0, sum value also 0. Next 0 plus 1. So here carry is 0 and sum is 1. 1 plus 0, carry is again 0 and sum is 1. Then 1 plus 1 is called as 1 0. So while adding 1 plus 1, it's called as 1 0. I mean it's 10. So here the carry is 1 and some value is 0. Okay. So now based on these two tables, so we're going to simplify this two table. So with the help of K-map simplification. So we're going to find out simplified output for carry and simplified Boolean expression for sum. So first for carry, so obviously we are having a 2 input variables. So when you are having a 2 input variables, obviously we shall use a 4-cell K-map. So design a 2 separate 4-cell K-map, one for sum, another one is for carry. So under that 4-cell K-map, we know the K-map structure. So it's called 0, 1, decimal order we know 0, 1, 2, 3. So just fill that values accordingly. So for 0, the output is 0. So no need to fill 0 values. Next for 0, 1, so output is 0. Under carry, so output is 0. Then for 1 0 is 0. Then for 1 1 it's 1. So under carry, so only we are having a single one. So just map that as a single variable mapping, group it. Then based on the grouping, we can write the answer as AB for carry. So the output for carry simplified expression is A into B. Similarly, do it for sum. For 0 is 0, For 1 mark as 1, then for 2 it's 1, for 3 it's 0, so no need to map 0. So we have to make a here two single cell grouping here. So do a two single cell grouping, then based on that we can able to write the answer. For this first one we can write a bar b. So the product term, simplified product term is a bar b. Then for the second single cell grouping is we can write a b bar. So we can write it, we know the XOR gate simplified term. So a b bar plus a bar b we can write as a exclusive b. So we are writing a simplified term. SC should be equal to sum should be equal to a XOR of b. Okay, or else you can write a direct answer like SA should be equal to A B bar plus A bar B. So now based on the simplified expression, we are making a logic diagram. So A and B is the two input variables. So we are taking a two input lines. So from that, we are making a logic diagram for the sum and carry. For carry, so only A into B. So C should be equal to A into B. So use a indicate. So we can make it A into B. So it's a simplified diagram for carry. Then for sum, so A XOR of B, so we can use directly XOR gate here. So A XOR of B should be equal to sum. So we can make a logic diagram. So this for half order design. Next one, full order. So half order we did for 2-bit addition. Full order means it's a 3-bit addition. So 3 input variables will be there. So you are taking as A, B and C input. Okay, so these three are the input variable. Then even while doing a 2-bit or 3-bit or even 4-bit addition, so we'll get a two output variable. One is called carry, another one is called sum. So carry we are taking as C out and sum we are writing as S. So now while doing this 3-bit addition, so first complete the truth table, then from the truth table we can make a simplified boolean function by using k-map, then we can make a logic diagram. So first, so when you are having a 3 input variables, so obviously we have a 8 possible input combination. 2 power 3 should be equal to 8, so 8 possible input combinations will be there. So starting from 000 to 111, so 000. So while adding 0 plus 0 is 0, again 0 plus 0 is 0. So sum also 0, carry also 0. Next, while adding 0 plus 0 is 0, then 0 plus 1 is called 1. So carry is 0, sum value is 1. Same, 0 plus 1 is 1, 1 plus 0 is 1. So carry is 0, sum is 1. Then 0 plus 1, 1. Then 1 plus 1 is called as 10. So 10 means carry will be 1, sum value is 0. Okay. So next 1 plus 0 is 1. Again 1 plus 0 is 1. So carry is 0, sum is 1. Next 1 plus 0, 1. 1 plus 1 is 10. So carry is 1, sum value is 0. Next 1 plus 1 is 10. 10 plus 0 is again 10. So here carry will be like 1, sum is 0. Next 1 plus 1, 10. 10 plus 1 is called as 11. So both carry is 1 and sum also it's 1. Now substitute this truth table in the k-map. So find out the simplified answer. So here we are having a 3 input variables A, B and C in. So obviously we are now having a 3 input variable. So we should use 8 cell k-map, we should use it. So substitute this truth table value C out and sum value in the truth table. So first one for sum. So under sum, so when you are having 1 as a output variable, I mean 1 as output. So for under 1 case is having 1. So substitute 1 for 1. Then for 2 also it's 1. So it's called first cell is 0, then 1, 3, then 2. So obviously 2 cell will be as 1. Then for 4 it's 1. Then for 7 it's 1. So under these 4 cases output will be 1. So just group it as a separate single cell grouping. So we don't have any option for quad, pair and all. So obviously we have to make it as a single cell grouping. Then after making single cell grouping, write the simplified answer. Like for the first cell, first mapping, single cell mapping, A bar, B bar, C in will come. So similarly second one, A bar, B, C bar will come. Then the third one, A, B bar, C in will come. Then uh, fourth one, A, B, C in will come. Okay, then simplify that. While getting simplification, the answer sum value will be A XOR of B XOR of C in. So this is a simplified answer for sum. Similarly, do it for carry C in. Substitute the output of carry. So for 3, it's 1. So substitute directly for 3 is 1. Then 5, 6, 7. So under these three cases, output will be 1. So substitute as 1, 1, 1. So here we can make it like a 3 pair mapping. 3 pair grouping can be done. So do the 3 pair grouping. So based on that, write the answer. For this one, uh, B C in will come, yes, B into C in. Then for this grouping, I mean 5 and 7, it's called A C in. Yes, it's called A C in. Then for 5 and 7, sorry, 6 and 7, the answer will be A into B. So A into B. So you are getting a 3 product terms you are getting in C out. So C out should be equal to AB plus BC in plus C in into A. So this is the output you are getting. So based on this sum and carry output, we can make a logic diagram now. So for the logic diagram, for sum, it's nothing but A exclusive, B exclusive, C in. So directly we can use a 3 input XOR gate. So we are getting the output of sum. Next one for carry. So obviously under carry we are having a 3 product terms are there. First one for AB, then second one for B into C in, then third one for A into C in. So do a 2 input variable AND gate. So all the 3 product terms should be added by using OR gate. Then you are getting output for C out. Next, full order using two half orders. We know as a half order cycle, we are using one XOR gate and one AND gate. So as a full order cycle, we should use two XOR gates and two AND gates should be added by using OR gate. Then we should get output of full order. So we know how we are getting the simplified answer for sum. S should be equal to A XOR of B XOR of C, or if we are using the terms like X, Y, Z, X XOR of Y XOR of Z. Okay, then we should simplify the carry term, then only we can able to make it like full order cycle by using two half order cycle. So carry value we know like x y bar z plus x bar y z, x y z bar plus x y z. So simplify this term. While taking a simplification, we are getting the output of like xy plus z into x xr of y. So with the help of that, so we're going to make it like full order circuit by using two half order circuit. As I said earlier, we should use two XOR gates and two AND gate and one OR gate should be used. So here, so first XOR gate we can use it for X XOR of Y, yes, one and XOR gate. Then after that we can add a Z variable. Then we can use a second XOR gate. So for getting the output of like sum should be equal to x XOR of y XOR of z. So sum output is obtained. Next we should get a carry output. So for getting the carry output, so first AND gate you are using for this xy. So use AND gate, two input AND gate for getting xy. Then xy is connected. Then before that, so we should get this x XOR of y into z. Already we know x XOR of y we are having. So that should be connected. Yeah, getting the x XOR of y. Then z input is connected. So both are multiplied by using a two input AND gate. So the output of AND gate is x XOR of y into z. Okay, so now it should be added with this xy product term. So we are already having xy product term. So xy product term is just added with x XOR of y into z. So the final carry output is like xy plus z into x XOR of y. So this is the diagram for full order using two half order circuits. Next one, half subtractor. So same like how we perform half order, full order. Similarly, half subtractor and full subtractor. So half subtractor is for is a 2-bit subtraction. So you are taking a two input variable a and b. So while doing any 2-bit addition or 3-bit addition or even n-bit addition, so you are getting the two outputs. One is called difference, another one is called borrow. So first 2-bit addition. So same process we're going to use. I mean same steps we're going to use it. First truth table making. Then after that we have to make a scheme of simplification. Then logic diagram. So first 0 minus 0, obviously difference also 0, borrow also 0. Then 0 minus 1, so obviously we cannot do it like 0 minus 1. So in that case we are getting 1 borrow, so borrow is 1. So this 0 will be converted into 10. So 10 minus 1, so the difference will be 1. Next 1 minus 0, so obviously difference is 1. We didn't get any borrow, so borrow is 0. Next 1 minus 1, so obviously borrow is 0 and difference also 0. So from the two table, so you are making a simplified Boolean expression using k-map. So first one for difference, under difference, variable 1 and 2 is output is 1. So for 1 and 2 output is 1. So just mark it, map it. Then after that we have to make a two single cell grouping to do a two single cell grouping. So here also answer will be like difference is a bar b plus a b bar will come. So the simplified we can make it like d should be equal to a xr of b. Then for borrow, only single one is there under the case of 1. So you can make it like a single cell grouping here. So the answer will be A bar B. So based on that, we can make a logic diagram. So first for difference A XOR of B. So we can use a two input XOR gate, directly we can connect it. Then for borrow, so we should use one NOT gate for a input variable. So we need A bar. So use a NOT gate. Then it should be connected with two input AND gate can be used for getting the output of A bar B. Okay. Next one, full subtractor. Same, we're going to do a 3-bit subtraction. So like A, B and B in we are taking as an input variable. Output is B out is called borrow and D is called difference. Okay. So now we are doing a 3-bit subtraction. So 0 minus 0 is 0. Again 0 minus 0 is 0. So no difference, no borrow. So obviously both are 0, 0. Next 0 minus 0 is 0. Then again 0 minus 1 is not possible. So we have to get 1 borrow. So borrow is 1. Then this 0 will be converted into 10. So 10 minus 1 is 1. Next 0 minus 1 is not possible. So get 1 borrow. So borrow is 1. So it's become as 10. 10 minus 1 is 1. Difference is 1. So difference is 1. Next 0 minus 1 is not possible. Same we get 1 borrow. So borrow will become as 1. Then 10 minus 1 is 1. Again 1 minus 1 will be 0. So the difference is 0. Next 1 minus 0, 1. Again 1 minus 0 is 1 only. So the difference is 1. We didn't get any borrow. So borrow is 0. Next 1 minus 0 is 1. So again 1 minus 1 becomes 0. Okay, the difference is 0, borrow also 0. Next 1 minus 0 is 0. 0 minus 0 is 0. So both borrow and difference both will be 0, 0. Next 1 minus 1 is 0. So here it becomes 0. Next 0 minus 1 is not possible. So get 1 borrow. So it's become as 10. 10 minus 1 will be 1. So the bar difference also becomes 1. So now substitute these truth table values in K-map, 8 cell K-map. So find out the simplified answer. So we are getting for difference, we are getting the simplified answer is D should be equal to A XOR of B, B XOR of B in. Then for similarly for borrow B out, A bar B plus A bar B into B in. So we are getting as a borrow output. So now substitute this difference and borrow output equation for making a logic diagram. So obviously 3 input XOR gate directly we can use it for difference A XOR of B XOR of B in. We can do it directly. Then for B out, so obviously we require a 3 2 input AND gate on OR gate is required. So connect the expression like A bar B plus A bar into B into B in. So use a three two input AND gate and one OR gate should be used. So by that we can able to make it this full subtractor difference and borrow. Thank you. We'll continue other combination logic cycle in the next session.